Faculty of Electrical Engineering and also a member of Team Twistbox. I will represent your work about smart house and demand-side management with a photovoltaic system in a house which is made in desert climate. I apologize because text in our presentation is in Serbian. This is my first English presentation and I hope it will be comprehensive enough. So traditionally, in power system, electricity is generated based on fossil fuels. But the problem with the generation of electricity in coal power plant is that it causes severe ecological problems. And the other problem we have is that resources of fossil fuels are limited. And that's why renewable energy sources are becoming more and more significant in power system. The problem with renewable energy sources is their intermittent nature. It means that we cannot control unplanned changes in primary resource. And one of the solutions for this problem is demand-side management. Just a second. Demand-side management means that we will make some control activities so that we can change the pattern of consumption in a way that we achieve desired effect. At the same time, many other changes in the world of technologies are happening. And also, life standard is growing up rapidly. Electrical system in one household has to respond on all of these requirements. And that's why smart houses are created. Those are advanced, improved electricity systems in households which allow to its owners many possibilities and many improved functionalities. For example, owner of this kind of system can remotely regulate the temperature in his house. Also, these houses have a smart lighting system, and they can also allow charging of electrical vehicles. But one of the most important features these systems have are demand-side management possibility. So, the owner of one of these systems may have interest into synchronizing diagram of production and consumption in its object. That can be achieved in two ways. He can use energy storage system, electrical batteries, which can allow him to store surplus of energy he has from his photovoltaic system, and when the production of photovoltaic system is not enough for his own load, then he can use stored energy. That way, his house does not have interaction with external grid. The other way to achieve his goal can be demand-side management. Appliances in-house which can be controlled and managed are those who have thermostats in themselves. In the first place, if we talk about desert climate, I think on air conditioning devices, also on refrigerators and freezers. But devices which can also be managed and their pattern can be changed in time are machines for washing and drying. So here we have a principle of work of air conditioning device. His main task is to maintain temperature between minimum and maximum temperature around desired one. So when temperature is decreasing, electricity consumption exists, and those are green rectangles on this photograph. And when after that, when the minimum temperature is reached, then we do not have electricity consumption anymore, and temperature is rising up to maximum. And this cyclic operation of air conditioning device can be used for demand-side management. For example, if we see that there are some cloud in next few hours and we will not have production from our photovoltaic system during that time, we can make that those off periods are at the same time. So we will not use electricity, and that is good for our self-sustainability. And one of this system will be represented during the competition Solar Decathlon in the Middle East in Dubai. And another innovation we want to introduce in our system is combination of AC and DC system, which is also up-to-date topic in power systems. We want to allow some of our devices to be plugged into DC voltage, for example, lighting and TV, and the other will be plugged into AC voltage. And this is the drawing of the main elements of our system. We have photovoltaic system, which produces DC voltage. We have battery 1 and charge controller, which will adjust voltage of photovoltaic system to the charging voltage of battery. We have inverter, which will convert DC voltage to AC voltage, and another battery. You may wonder why we have two batteries. Well, the reason is that competition of the rule limit the size of the inverter on the 8 kilowatt on the AC side. So we created we want to design this kind of system because battery 1 is here to store energy when production of photovoltaic system is very large and the inverter cannot transfer it on the AC side. On the other hand, when our consumption is larger than 8 kilowatt, we can use energy stored in battery 2. And that's the reason why we have two batteries, so we can achieve the minimum exchange with the external grid. Thank you for your attention. Are there any questions?
Thank you.